Welcome to Vignana Jyoti Mathematics YouTube channel. Today I am here with you to explain real numbers chapter for 10th class students. In this chapter I would like to explain the applications on Euclid division lemma. Isn't it? Here the problem is use Euclid division lemma to show that the square of any positive integer is of the form 3p or 3p plus 1. So here according to the problem, the RTP is nothing but square of any integer. That means square of any number is in the form of either 3p or 3p plus 1. So we can prove this by using Euclid division lemma. Then we go for solution. Okay, here the solution have two methods. Method 1 I would like to explain here, and method 2 also briefly I have to explain later. First come to method 1. Here you write down the RTP as usual. Any square of a number should be takes 3p or 3p plus 1. Okay, isn't it? Thereafter you have to compare this 3p or 3p plus 1 are in the form of bq plus r. You have to compare these two forms with bq plus r. Why? Because our Euclid division lemma is in the form of bq plus r. Therefore, whenever you compare these two forms with this bq plus r, here clearly you can observe that b is nothing but 3. Here also 3. So the color indicates to understand easily. Therefore, b is equal to 3. Now, I am going to applying Euclid division lemma by taking b is equal to 3. Therefore, a is equal 3q plus r. Here, since b is equal to 3, r can take 0 to 2. Only 3 values. Now, according to our RTP, we have square the number. If you have a number, here I have a as a number. Then what we have to do? You have to square the number. Therefore, I have to square this a. For getting square, I have to square on both sides. Isn't it? Therefore, what happens? If put square here, it becomes a square. This becomes 3q plus r whole square. Isn't it? Now, if you observe the RHS, it is nothing but in the form of a plus b whole square. Isn't it? If you compare this one with a plus b whole square, here clearly a is nothing but 3q. Isn't it? Here a is first term, here 3q is first term. Therefore 3q is equal to a. I will write down rough work. Then if you compare r is in place of b, therefore b is equal to r. Then you have to expand the formula. The first term is a square. A means 3q. That means 3q whole square. You will put square to this 3 and you will put square to this q. This is nothing but 3 square 9. Then you write down q square as it is. That's why 9q square. Then come to 2ab. Here what is 2ab? You find out the value of 2ab. Here 2 is a constant. Here a is nothing but 3q. Here b is nothing but r. So 2 of 3q into r is nothing but 6qr. These are the rough work. So I will write plus 6qr. The last term is b square. B stands for what? R. Therefore it is becomes r square. Okay. Whenever you square here only, the problem will be easy to calculate. Okay. If you take the relevant r values, take r is equal to 0, then what happens? This whole equation becomes a square, 9q square as it is, then 6q as it is, then you put in place of r 0 plus as it is r square 0 square. That means I substitute where I can find r, I will substitute with this 0. So it clearly 9q square. Therefore 6q of 0 is 0. Here 0 square is 0. So the total sum is 9q square. Here it can be written as 3 of 3 square. That means this 9 is divisible by 3. Why? Because our forms contains 3. Therefore you have to check whether it is divisible by 3 or not. It is clearly divisible by 3. Therefore I will write 3 into 3 into q square. Whenever you assume this q square as p, it becomes 3 of p. This underlined part is equal to p. It gives 3p. It is one of our required form. then you will take r is equal to 1. If you substitute r is equal to 1 in this equation, you will get like this: a square is equal 9q square as it is plus 6q as it is. You will write r 1, then plus here also write 1, then go to calculation. This keep as it is, and this 6q into 1 is nothing but 6q. Here 1 square is nothing but 1. Thereafter it is 9 is divisible by 3 and 6 is also divisible by 3. Here 1 is not divisible by 3. So these two terms are divisible by 3. You see the underline. The underlying terms are divisible by 3. Therefore, I will take 3 as a common factor. Here you get 3q square. Here 2q. Isn't it? If you multiply these two terms with this 3, you will get these two terms. Isn't it? Then you write down plus 1 as it is. Now you can take this 3q square plus 2q here, consider as p. Then you write down 3 as it is. The bracket part becomes 2p by our assumption here. Then you will take it down 1 as it is. The arrow mark shows for comfortable understanding. Okay. Then this 3p plus 1 is one of our required form. Then the last one you will take r is equal to 2. If put r is equal to in this equation, the equation becomes a square is equal to 9q square, then 6q as it is. Then you will write in place of r 2. Here also you write 2 in place of r. Then this is as it is. Then 6q of 2 is nothing but 12q. Here t square is nothing but 4. Here 9q square can be written as 3 into q square. Okay. Here 12q can be written as 3 into 4 into q. Then 4 can be written as 3 plus 1. Now you see this is, here you can find 3. Here also you can find 3. Here also you can find 3. That means the underlined 3 terms having 3 as a common factor. Therefore I will take 3 as a common factor. Then write the remaining terms. It is nothing but 3q square. Then write down plus. Here 3 has already gone as a common factor. You have 4q. Here 3 also gone as a common factor. There is nothing. That means you have 1. Okay. Then you write down this one as it is. Isn't it? Then this whole part can be considered as p. Therefore this 3 as it is. Then the bracket value becomes 2p by our assumption. Then you will take it down 1 as it is. Okay. Then here also you will get 3p plus 1. It is one of our required form. In one case you will get 3p. In two cases you will get 3p plus 1. To take any positive integer, then you have to square and then divided with 3, you will get either 3p or 3p plus 1. Hence it is proved. Okay, isn't it? Here we have model 2 also. In method 2, come to RTP, then compare these forms with BQ plus R, then write down B, then applying Euclid division lemma. These are the common steps. From here only, we can find some changes. There in method 1, I will squaring this equation here only, but here I don't squaring this one. After taking the relevant values of r, I take r is equal to 0, then write down the equation. Thereafter I will square. Okay, then I will take r is equal to 1 and substitute r is equal to 1 here. The equation becomes a is equal to 3q plus 1. Again I will square both sides here. Then you will take r is equal to and write down the equation by putting r is equal to 2. Then again you will get squaring on both sides. Here you can squaring on both sides. Here you can squaring on both sides. Here you can squaring on both. That means how many times you have squaring on both sides? 3 times. This is first time and this is second time and this is third time. Here you have to squaring on both sides 3 times, whereas in method 1 we have squaring only one side. So that is very easy to you. Of course, if you go through this method, you will get the same answer. So if you feel which method is comfort to you, you can proceed. Okay. Thank you for watching this video.